so let me just share my notes. So problem number 5. Ooh. All right, so let's do question number 5. So this is question number 5. So it said, for the following, sketch a standard normal curve to shade the area representing the region and determine the area. So if you look at number 5, it says z is greater than or equal to negative 2.03. So first thing that you should kind of notice that is of important is that they tell you that it's a z value. Anytime z value is given to you, that means mu is automatically equal to 0. That means sigma is automatically equal to 1. So as soon as you see that you're finding the probability of a z value, the first thing that should be popping into your mind is that mu is equal to 0, sigma is equal to 1. So then what you want to go ahead and do is go ahead and draw this. So middle should be 0. And then you get negative 2.03. And look at the arrow. So if you look at the arrow is pointing to the right-hand side. So since it's pointing to the right-hand side, that means you shade the right side. So what we want to do, we want to figure out what the lower bound is, what's the upper bound is. So to figure out the lower bound and the upper bound, all you have to do is look at the graph. So by looking at the graph, you can see that the lower bound is this one because that's the lowest value that we have shaded. So we'll say negative 2.03. If you look at the upper bound, if you look at it, it doesn't really get cut off at any particular number. So since it doesn't get cut off at any particular number, we're going to say go all the way out to positive infinity. And if you're using the TI-84, you don't have a positive infinity, so you use 10 to the 10 power. All right. Any questions so far? I got the lower and the upper. Okay, so what I'm going to go ahead and do, I'm going to go ahead and do this in the TI-84 first. And then I'm going to go ahead and do this on the class calc. So for TI-84, let me clear this. First thing you want to do is hit second and hit the bars button. And then if you look at number 2, you want to do normal CDF. So for the normal CDF, you do the lower bound, which is negative 2.03. For the upper bound, we do 10 to the 10 power. And then mu is 0, sigma is equal to 1. You go to paste, and we get our answer for for number 5, which is 0.978. All right, so that's how you deal with the TI-84. Any question on how I deal with the TI-84? Okay, so up next, I'm gonna go ahead and switch over to class calc. So if we want to do it with class calc, you hit the stats button. You go over here where it says distribution / plots. And we go right here where it says normal distribution. So since this is a standard normal distribution, you put mean is 0, sigma is equal to 1. You click on CDF. CDF, the lower bound is negative 2.03. The upper bound is positive infinity. So if you look at it, you get 0.9788, which is exactly the same answer that we got when we did it with the TI-84. And that's it for class calc. Any question for how we did it with class calc? All right, so number 7. All right, so if you look at number seven is saying it has to be in between. So it's saying it has to be in between negative 0.26 and between 1.62. So I already have room up here, so I'm gonna do it over here. So if I want to do this, once again, you just want to draw this out. So the middle should be 0. So if you look at negative 0.26, negative 0.26, all the way to positive 1.62. So you want the in between, so you shade the in between. All right. So if you look at the mean of the standard deviation, the mean should still be 0. The standard deviation will still be 1. The only thing that I got to change my lower bound, my upper bound. So for my lower bound, it should be negative 0.26. For my upper bound, it should be positive 1.62. Any questions so far? I got the lower bound and my upper bound. All right, so I'm gonna go ahead and transition over. So we'll do this with the TI-84 first, and then we'll do it with Classical. All right, so for the TI-84, once again, you go to second, you go to VARS, we go to normal CDF. So if you look at the lower bound should be negative 0.26. My upper bound should be 1.62. And we go over here, paste, and you get 0.54, or pretty much that's 0.55. So if you want to do this with class calc, if I want to do a class calc, all I have to do is change the lower bound, the upper bound. So for my lower bound, we'll change to negative 0.26. For my upper bound, we'll put 1.62. And if you look at it, you get exactly the same answer, 0.5499, or pretty much 0.55. And that's it for problem number 7. Any question in regard to problem number 7? All right, which other question do we have in regard to the practice final exam? Cool, number 8. All right, so number 8 is pretty much just a flashback of test number 1. So if you kind of remember test number 1, we went over how to find the z-score. So the formula to find the z-score is equal to x minus mu divided by sigma. X in this case is 9. Mu in this case is 11. Sigma in this case is 2.62. So if you do 9 minus 11, 9 minus 11 is, oops, sorry about that, is negative 2 divided by 2.62. If you do negative 2 divided by 2.62, you get negative 0.76. And that's number 8. So number 8, pretty much the key word here is they determine the z-score. So they want you to find what the z-score is. So it shouldn't be that bad. Any question in regard to number 8? Any other question? All right, 16. Let's move on to 16. suppose you roll 2 dice. All right. So number 16, it says suppose you roll 2 dice. So it says what are the probability of rolling a sum of 11, 4, 8 with 3 rows? You're gonna say yeah, you could just skip 16. 16 is not gonna be on the test. So don't worry about number 16. All right. Which other question? All right. So for question 17, it says a bag contains 5 white balls, 6 blue ball. Oh, sorry, 6 red ball, 9 black ball, and determine the probability of pulling out. So they want to know what's the probability of getting a black or a white ball. So we want to find the probability that we get a black or a white ball. So this one you kind of have to just realize since we want either one of those two, pretty much you have to figure out that this is a disjoint event or a mutually exclusive event. Because you could either get a black ball or you're gonna get a white ball, but it's impossible for you to get a black and a white ball in one single pull. So for this one is a disjoint event. So all you have to do is get the probability of black and add it to the probability of white. So the probability of black is 9 out of 20, plus the probability of white is 5 out of 20. So that will give you 14 out of 20. So then if we do 14 out of 20, you get 70%. And that's it for 17. So for this one, since they use the or statement means either or. So that means you get the probability of black and you get the probability of white. You add those two up and then that's it. All right, so let's do 19, then we'll do 10. All right, so if you look at 1919, we want to find the probability a white bulb and then a black bulb without replacement. So before we get into the white ball and then a black ball, we're gonna go into what does it mean when it says without replacement or with replacement. When they say without replacement, that means once you select that ball, you can't select that ball again. But if you do a with replacement means once you select that ball, you put it back into the bag and then I could reselect that ball again. So if we're doing this without replacement, I mean, once you select that ball, I can't select that ball anymore. So for number 19, here. So let me do that up here. Oh, that's too thick. All right, so for number 19, we want the first ball to be white, and then we want the second ball to be black. And for this one, we're doing it without replacement. So without replacement meaning, once you select the object, I can't select that object again. So we want the first ball to be white. So we go, how many white balls do we have? Well, you have 5 out of 20 balls. So if we're doing this without replacement, that means once I select that white ball, I have one less white ball to choose from. So now though it being out of 20, it'll be out of 19 because you have one less ball. So we want to find probably the first one is white is 5 out of 20. So now we want to find the probability that the second ball I select is black. So assuming the first ball I selected was white, the probability that the second ball is black will be 9 out of 19. All right, any question? I got 5 divided by 25 and 9 divided by 19. All right, so I'm gonna go ahead and just multiply these two out, and then that's our answer. So you go 5 divided by 20, multiplied by 9 divided by 19, and you get 0.1184. All right, so that's without replacement. Any question without replacement? All right, so let's see if I could fit this in. So we're gonna do it with replacement. All right, so now we're gonna do width replacement. So width replacement just means once I select that ball, I could re-put it into the bag. So that means you're always gonna have 20 balls. So the probability the first ball is white will be 5 out of 20. Cool. So now we want to find what the probability the second ball will be black. So the probability the second ball will be black will be 9 out of 20. Because since we're doing this with replacement, that means once I select the first ball, I put it back into the bag. So since I put it back into the bag, that means you still have the original 20 balls when you're selecting the second ball. So we'll say 5 divided by 20 times 9 divided by 20, and you get 11.25. And that's it in regard to 19. So without replacement, once you select the object, you can't select that object again. With replacement, I mean, once you select that object, you can actually reselect that object again. All right, so that's it for 19. Any question in regard to number 19? All right, so I'm gonna go ahead and we're gonna go ahead and do number 10. All right, so if you look at number 10 said let X be a random observation that has a normal distribution with a mean of 12 and a standard deviation of sigma equal to 2. So it says find the area under the normal distribution curve for the following. All right, so they tell us this is the normal distribution. So if we're doing this in our calculator, that means we're gonna be either using normal CDF if you're using the TI-84. If you're using ClassCalc, you're gonna use the normal distribution. So for this one, we'll draw it out. It tells us mean is equal to 12. So if you look at number 10, it says between 7.76 and 12. So that's the area that we want to find. So if we're entering this into ClassCalc or the TI-84, you're gonna need this information. Lower, upper. So for mu will be 12. Our sigma will be 2. Lower bound will be 7.76. My upper bound will be 12. So any questions so far? I got mu, sigma, my lower bound, and my upper bound. All right, so I'm gonna go ahead and get transfer over to class calc. I'm gonna do this in class calc. Then I'll show you how to do the TI-84. All right, so if you want, you could actually still use this one. All you have to do, you change the mean and standard deviation. So the mean is 12. Standard deviation is 2. So if you look at the lower bound is 7.76. If you look at the upper bound is 12. So if you look at the area that we got 0.48, pretty much 0.483. So we'll get the probability is 0.483. All right. And that's your answer for number 10. Any question in regard to how I did it on class calc? All right, so let me do it with the TI-84. All right, so on the TI-84, you go to second, you go to vars, and you want to go right here where it says normal CDF. For my lower bound, we put 7.76. For my upper bound, we put 12. For my mean, we put 12. For standard deviation, we put 2. Then we put pace. So the final should be next week. Next week, you're gonna have all the way from Monday to Friday to finish up the final. All right, so if you look at, if you do it with the TI-84, you get exactly the same answer at 0.483. And that's it in regard to number 10. Any follow-up question in regard to how I did number 10? All right. Any other question in regard to the practice exam for the final? All right, 34. Yeah, so if you pay attention to the announcement that I made, I said skip 34, so skip 34. Any other question that I told you to do? Also says skip 35. All right, let's do 13. So if you look at number 13, it said find the probability or find the area under the normal distribution curve for the following. So it says to the left of x is equal to 9.72. So 9.72 is somewhere over here. It says the left. This is the left side.
I think your screen has frozen. It's still on the calculator.
Okay. Let me go over. All right. So pretty much that's the drawing. So if you look in the middle should be 12 because that's still our mean. And if you look at number 13, it says to the left of 9.72. So 9.72 is to the left of 12 because 9.72 is smaller than 12. And then since it said find the area to the left of 9.72, you say the left-hand side of 9.72. All right, any questions so far for that drawing? All right, so let's figure out what we're gonna enter in for our calculator. So in our calculator, we have to enter this information. So if you look at mu is equal to 12, standard deviation is equal to 2, lower bound is equal to negative infinity, or negative 10 to the 10 power if you're using the TI-84. And then for the upper bound should just be at 9.72. All right, so that's how you want to enter it into the TI-84 or into ClassCalc. So let me show you how to do that with the ClassCalc, and then we'll do the TI-84. All right, so if we're doing this with the TI-84, well, sorry, with ClassCalc, if you look at it, I already have the mean of 12, standard deviation of 2. All I have to do is change the lower bound and the upper bound. So for the lower bound, I'm just going to erase that. And now it should be negative infinity. I'm going to change the upper bound to 9.72. 9.72. All right, so if you look at the probability that I get the probability of 0.1271. So if you're doing it in ClassCalc, that's how you want to do it in ClassCalc. If you're going to do it with the TI-84, for the TI-84, what you want to do, you want to hit second, you want to hit vars, and you want to do normal CDF. So for the lower bound, once again, you want to put negative 10 to the 10 power, because we want to do negative infinity, but just remember your calculator doesn't have that button to do negative infinity, so we do negative 10 to the 10 power. Then for the upper bound, we do 9.72. And then you go to paste. And if you look at it, you got exactly the same answer as we did with ClassCalc. So it doesn't matter which one you do it for, you should still get the same answer. So that's it for question number 13. Any question in regard to 13? Okay, so let's do 28. All right, so we'll do 28 and then we'll do 20. So 28 said we'll experience a rise in blood pressure given a report of loss of sleep. Okay, so rise in blood pressure, that's gonna be BP. So anywhere you see me putting BP, that's gonna be blood pressure. And let me transfer back to my notes for that way you can see what am I talking about. So for 28, if you look at it, we'll experience a rise in blood pressure. So rise in blood pressure will be BP. For loss of sleep, where you put S for loss of sleep. Okay. So if you look at this problem, it says find the probability that will experience a rise in blood pressure given a report of lost sleep. So given is the keyword that's telling me this is a conditional probability. So what we want to do, we want to find the probability they have a rise in blood pressure given that they have a loss of sleep. So if you remember the formula for a conditional probability, the formula for a conditional probability is the probability that both events occur at the same time divided by the probability that the given will occur. So what we want to do, we want to find the probability that a person has both a rise blood pressure and suffer from loss of sleep, and we want to divide it by the probability of a person, yes, suffering from loss of sleep. So for this one, how many people do they tell us have high blood pressure or rise blood pressure and suffer from loss of sleep? Yeah, 12. So for this one, we'll put 12 out of the total amount of people we have, which is 100. And then you want to go ahead and look at how many total people suffer from loss of sleep. Well, if you look right here, they tell us 18 out of 100. So this will actually just become 12 out of 100 times 100 out of 18. The 100 will cancel out. So you get 12 out of 18, which is actually a 66.6%. And that's it for 28. So right here, the keyword is given. Once they tell you it's given, they're telling you this is a conditional probability, and this is the formula that you want to use for conditional probability. All right. Any question in regard to 28 before I move on to 20? All right, so let me go on to 20. All right, so if you look at 20, it says give two marginal distribution for education level and status. So pretty much marginal distribution, if you remember, marginal distribution is pretty much the probability of a row or a column occurring. So for this one, it says find the marginal distribution for education level. So for education level, I could either find the probability that someone have less than a high school degree education, or I could find the probability they have a high school degree education, or I could find the probability they have more than a high school education. Each one of these will be considered a marginal distribution because we're finding the probability of the column. So for less than a high school diploma, you put 1105, and this is where I get the 1105, and you divide it by the total, which is 2646. Or I could get the probability somebody have a high school education level. So that's the 496 divided by 2646. Or I could get the probability somebody has more than a high school diploma. There you go, 1045 divided by 2646. All right, so those are the three marginal distribution for education level. If you look at this one, they say give me two marginal distribution. So either one of those probability will suffice as a marginal distribution. Any question in regard to for marginal distribution for education level? All right, so they also want the marginal distribution of status. So for status, I could either get that they're better off, or I could get the probability that they're the same, or I could get the probability that they're worse off. If I want to get the probability that they're better off, you get the 1,213 and you divide it by the total, which is 2646. Or I could get the probability of same. Same will be 580 divided by the 2646. Or lastly, I could get the probability that they're worse off. So you get 853 and you divide it by 2646. And that's how you do problem number 20. Any question in regard to problem number 20? Cool. All right. Any other questions? All right, 30. 30, 30, 20, 30, 20. All right, then 32, 33. For 32 and 33, don't worry about this. This is not going to be on the final. So 32 and 33, you can just scratch out. It's not going to be on the final. All right, so I got for 30. All right, so if you look at number 30, it said will experience neither of the two side effects. So for this one, you can kind of draw a Venn diagram. So we have people who are going to suffer from sleep loss, or you have people who are going to suffer from blood pressure or high blood pressure. So if you look at this, they already told us how many people suffer from both of them. So we have 12. So 12 people suffer from both high blood pressure and loss of sleep. If you look at how many total people suffer from sleep loss, is 18. But since you already have 12 right here, pretty much right here you put 6. Because if you go 6 plus 12, that will give you the 18. All right, so then if you look at blood pressure or high blood pressure, is 26 people. But same thing, since you already have the 12 in the middle, if you do 12 plus 14, that will give you the 26. All right. Any questions so far? I got the 6, 12, or the 14. All right. So if you look at that, those are how many people are suffering from those side effects. But the thing is, we want to focus on people who are not suffering from those side effects. So if you look at how many people are suffering from those side effects, how many people are suffering from those side effects? Well, if you do 14 plus 12 plus 6, you get 32. So that means 32 people are suffering from those side effects. And if you look at it, they tell you there's a total of 100 people. So if I know 32 people are suffering from those side effects, if I want to find out how many people are not suffering from those side effects, we can just subtract it. So we could do 100 minus 32. If you do 100 minus 32, that's 68. Yeah, it should be 68. So if I have 32 people who are suffering from those two side effects, that means we have 68 people who are not suffering from those side effects. So if you look at part 30, or if you look at number 30, it says will experience neither of those two side effects. So for this one, will you put, we'll put it right here. We'll put 68 out of 100, which is 68%. And that's how you want to do number 30. All right. So the reason why we got 6 in the diagram, because if you look at how many total people, if you look at how many total people suffer from sleep, from loss of sleep, the total, there's 18 reported loss of sleep. So if you have 12 people right here who suffer from sleep loss and pretty much sleep loss and high blood pressure, that means we have 6 people who only suffer from sleep loss, because all you have to do for this one, you have to do the 18 that suffer from the sleep loss and subtract it from 12. If you do 18 minus 12, you get 6. So that's where the 6 come from. So the 6 come from that we already have 12 that suffer from sleep loss in the middle. So that means there's only 6 left. Any other question in regard to number 30? All right. What other question do you want me to go over?
Can you do 26?
26. Sure. So if you look at 26, it says, assume that the weight of a certain brand of cookie are normally distributed with a mean of 32 ounces and a standard deviation of 0.3 ounces. Determine the probability that the mean weight of a random sample of 20 packages of this brand of cookie will be, and then 26 is between 31 and 33 ounces. All right, so right here, you kind of want to notice they give us mean. Mean is 32. They give us standard deviation. Standard deviation is 0.3. All right. Everybody good so far with the mean and sigma?
Yes.
All right. So one thing that's a little bit different in this problem, they give us a random sample. So they tell us the random sample of 20 packages. So that means we're doing n is equal to 20. So that means what we have to do for this standard deviation, we have to divide this standard deviation by square root of 20. Because if you remember, anytime your sample size is bigger than 1, you want to use this formula for standard deviation. Because we call it standard deviation of x bar, which is standard deviation divided by square root of n. So since they give us a sample size bigger than 1, you have to divide your standard deviation by the square root of n. So in this case, we're going to do 0.30 divided by square root of 20. Any questions so far on mu and sigma? Alrighty. So if you look at 26, it says find the probability is between 31 and 33. So if I draw this out, 32 should be in the middle. So we want it to be between 31 and 33. So here go 31. Here go 33. And we want it to be in between. So that means my lower bound should be equal to 31. My upper bound should be equal to 33. So when I go to ClassCalc or my TI-84 for mu, you can put 32. For sigma, you have to do 0.3 divided by square root of 20, because if you don't do that, you're going to get the wrong answer. And then for the lower bound is 31, upper bound is 33. Everybody good so far on that? All right, so let's go to ClassCalc, and then I'll do it with the TI-84. So for ClassCalc, so I want to adjust my mean. So my mean in this case is 32. My standard deviation, do 0.3 divided, and I'm going to do square root of 20. My lower bound in this case will be 31. My upper bound will be 33. Okay. All right, so if you look at ClassCalc, it says 1. So saying there's a 100% chance of this occurring. And that's it for how to do with ClassCalc. Everybody go for ClassCalc. All right, so let me switch it over to the TI-84. Let's switch it to the TI-84. So for the TI-84, you could go second, you could go to VARS, you go to normal CDF. So for the lower bound, we put 31. For the upper bound, we put 33. For mu we said was 32. And sigma will be 0.3 divided by square root of 20. So if you go over here to paste, cool. You also get 1. And that's how you do 26. So for 26, you just have to remember to adjust the standard deviation. So instead of putting 0.3, you do have to put 0.3 divided by square root of 20. Because if you forget to put the square root of 20, if you look at it, you'll get a slightly different answer. It's not that much of a difference in this case scenario because you get 0.99914, but it will give you a wrong answer. All right, but that's it for 26. Any follow-up?
What chapter is this particular problem in?
Let me look through my notes real quickly. I think it should be like 15. Yeah, for the notes, it should be chapter 15. So if you go to chapter 15, you'll find all of the notes for that problem that we just did.
Thank you.
Yeah, you're welcome, no. All right. So any other question in regard to the practice final like that? All right, 37 and 40. Sweet. So for 37, so the first thing you should notice for 37 is a binomial distribution. So the reason I know the binomial distribution because they tell me how many trials we're gonna do. So if you look at it, they tell me we're gonna do a trial of 10, and they also give me the probability of success, which is 0.15. Oops, sorry. Let me switch it over to the notes.
Yeah.
All right. So if you look at 37, first thing you should just recognize that this is a binomial distribution. The reason why it's a binomial distribution, if you look at the set amount of trial, they tell you they're gonna do this 10 times. Also, if you look at it, they give you the probability of success. So they give you a probability of success of 0.15. So like kind of like an easy way to distinguish this one from the last problem that we did. If you look at the last problem that we did, the last problem, they actually gave us the mean and they also gave us the standard deviation. If you look at this problem, nowhere do they give us the mean or the standard deviation. They give you N and P. All right, so that's the first thing. Yes, being able to distinguish is a binomial distribution. So if you look at 37, it says determine the probability of getting one wrong number. So saying of the 10 attempts, what's the probability that one of them give us a wrong number? So that means X is equal to 1. So if you look at 37, since 37, they're asking for just one singular X value. We only want to find the probability when X is equal to 1. This is going to be binomial PDF. So right now, I'm going to go over to the TI-84. And using the TI-84, I'm going to solve this question. So you go to second, you go to vars, and you go all the way down to binomial PDF. So for trial is 10, P is 0.15, and X is equal to 1. You go to paste, and you get that for your answer. So say 0.3474. And that's it on the TI-84. Everybody go who's using the TI-84 how to get this answer? Sure. Up next is for the people who have class calc. So if you have class calc, let me erase this. So if you have class calc, you go to stats, you go to distribution, And if you look right here, you go to binomial distribution. So for binomial distribution, enter your n, which is 10, enter your p, which is 0.15. And then if you look at it, it's asking you if you want to do a CDF or a PDF. CDF if you want a range. PDF if you want a singular value. I want to find the probability of a singular x value, and just enter 1. And we're done. So that's how you do 37. Any question for 37? All right, so let's do number 40. So let me transfer back to my notes. All right, so if you look at number 40, it says assume that you are testing such as a provided by making 100 requests. Determine the probability of getting at most 13 wrong number. So for this one thing you should notice, they changed the n on me. The n is now 100. So instead of it being 10 requests, now they're doing 100 requests. And we want to determine the probability of getting at most 13 wrong number. So that means x could equal to 0, 1, 2, 3, 4, all the way down to 13. So if you look at number 40, instead of wanting a singular x value, you want a range of x value. So pretty much we want it to be all the way from 0 to 13. So for this one, you do want to use binomial CDF because you want to find a range of 0 to 13 versus just finding one number. All right. Everybody good that n is equal to 100 and x is equal to 0 all the way to 13? Okay, so let me go ahead and do this on the TI-84, and then we'll do this on Class Calc. All right, so for the TI-84, you go to second, you go to VARs, and we go to binomial CDF. So trial will be your n, so n is 100, p is 0.15, and x is the highest x value that you have in your range. So if you look at our range, it went from 0 all the way to 13. So what I'm going to do, I'm going to say x is equal to 13. Because what I want the binomial CDF to get me 13 all the way down to 0. So we go to paste. All right, so you get 0.3474. Everybody go on 0.3474. So let's go ahead and now let's do this in Class Calc.
That's like the same answer as 37, right?
Yeah, it's pretty much the same answer. All right, so in Class Calc, if you do it, well, the n and the p is the same. The only thing we're going to change is CDF. So for CDF, we'll put 0 all the way to 13. Forgot to change this to 100. All right. So if you look at it, once you change it from 0 to 13, you get this answer of 0.3474. And that's your answer for 40. Any question in regard to number 40? All right. Any other question in regard to the review? 46. All right, so let's do 46. All right, so if you're doing 46, if you look at 46, it says determine the correlation coefficient. So that's pretty much just R. So they just want you to find R. So I'm gonna show you how to do this with ClassCalc. Then I'll show you how to do it with the TI-84. But pretty much all they want you to do is just to find R. So here's my X value, here go my Y value. So let me go ahead and transition over to ClassCalc. All right, so in ClassCalc, I kind of found this out. If you actually hit this plus button, you could hit table, and then what you could do, you could just enter this as a table. So you could do 0.20, 0.30, 0.40, 0.50, 0.60, 0.80, and then 1.1. And then what you could do, you could either do 20, 30, 22, 30, 38, 23, and 30. All right, so you can just enter into the table. Once you enter that information to the table, all you have to do, you go to stats. This case scenario, you want to go to advanced, and you want to go right here where it says linreg. So right here, you want to tell it where the X value is. So you have the X value in X1, so we put X1. Then you want to tell it where do you have the Y value? Well, the Y value is in Y1. All right. So if you look at it, it gives us R is equal to 0.2976. And we're done. So say 46 is R is equal to 0.2976. Everybody get how to find R? And if you look at problem number 47, 47 also asks determine the regression equation. So we pretty much found the regression equation also, because if you look at this one over here, that's our equation. So we could put 6.01 x plus 24.22. And that's what you had to do for 47. All right. Any question in regard to 46 or 47? All right, so now I'm going to show you how to do this.
So you just you can use the table, and then on the linreg you put x1, y1, or whatever it's asking you, then you can get the y and r.
Correct.
Okay.
Yeah. All right. So if you want to get the table, there should be a plus sign. Let me check the app on my phone to make sure they have that plus sign.
It does.
All right. So you press the plus sign, and then it should give you an option to type in table. And then you get the table again. All right. But any question in regard to ClassCalc? All right, so let me transition over to the TI-84. Yeah, for the answer key, I got that answer by doing it by hand. So that way it's slightly off because I did it by hand. Because also, if you look at the answer key for R, I rounded it up to 0.3. So that way it's slightly a little bit off. So, But if you do using ClassCalc, that's the answer you should get by using ClassCalc. All right, so if you're doing this on the TI-84, all you have to do is hit the stats button. You want to go edit. So I have to clear all of this. So to clear it, you just pretty much highlight the top column and hit clear and then hit enter. And that will clear up everything for you. So I'm gonna go ahead and enter the numbers. So 0.2, 0.3, 0.4, 0.5, 0.6, 0.8, and 1.1. So then you go 20, 30, oops, not 40, 22, 30, 38, 23, and lastly 30. So you just want to make sure if you have the TI-84 that you enter it into L1, L2. All right. Everybody go who's using a TI-84. All right, so if you're using a TI-84, what you want to go ahead and do next, go to Stats, move it over to Calculate, and if you look at number 4, you want to use number 4 where it says lin reg AX plus B. So if you look at mine, it's asking me where is my X list? So the X list I'm telling it is in L1. Where is the Y list? I'm telling it is in L2. We'll go over here, calculate. Cool. All right, so if you look right here, R, they gave me 0.2976, which is exactly what we got with ClassCalc. If you look at the linear regression is slightly a little bit different because in ClassCalc, it already inputted the information for us. But for you have to do that manually. Because if you look on top where it says Y equal AX plus B, so instead of putting A, you put 6.01. Instead of putting B, you put 24.22. But that's how you deal with the TI-83. All right. Any question for the TI-84?
I'm sorry, what was A and B again? Like, what do they correlate to?
A, in this case, is your slope. B will correlate to being your y-intercept. And also, if you just look at the top, where it says y equal ax plus b, that's where you want to substitute the a. So if you look at it, it says a times x. So instead of putting a times x, you do 6.01 times x. And then you add it to your b, which is 24.22.
Okay.
Everybody good for the TI-84? Cool. And for the test, it shouldn't really matter if you round up or down. Like, I'll make the answer kind of a little bit different. So that way, if you round it up or down, like you should still get the same answer. All right. Any question in regard to this last problem of 46 and 47? All right. Any other question? All right, so if there's not any further questions, what I'm gonna do, I'm gonna just end today's meeting, and I'll be having office hour at 11:15 all the way to 12:15. So if you do have any further questions, you can just ask me during my office hour. So just remember today, exam is due by 11:59 p.m. today. So do that because once the due date is passed, I can reopen that exam for you. All right. Any last minute question before I close down the meeting? Okay, so I'm gonna close down the meeting. So I'll see everybody if you come to my office hour, but if not, I'll see you on Thursday.